Hi everyone, Mrs. Pasega here, and today we're looking at using the function generator to charge and discharge a capacitor. So a function generator can be turned on with this button right here, and its job is to put out a bunch of voltage at different frequencies. So notice there's a voltage knob on this side, a frequency knob on this side. But for something like a capacitor that has a set positive and negative side, I don't want this to switch back and forth between positive and negative. Because of how this is constructed, this side with the plus must stay positive. This side with the negative must stay negative. So I don't want it switching back and forth. 1,000 hertz means my voltage would be switching positive and negative 1,000 times per second. So I don't want that. Anytime I want direct current, I'm going to hit waveform, use the voltage knob to scroll down to DC, direct current. And what this will do is it will make sure the current stays going in one direction. Functionally, it sets the frequency equal to 0. So now let's charge this up. I'm going to take the positive wire. So this time it's connected to the positive side, and I'm going to connect positive to positive. I'm going to take the negative wire, connect negative to negative. And on the voltage knob, I'm going to turn it up. And I'm going to make sure I'm turning only the voltages to positive. Down here on the side, you're going to see this number, the amps. And when you see that's turned to 0, you know that it is done charging. Think of this as this potential difference is separating protons and electrons from each other. And when the current goes to 0, it's done doing that separation. So that's charging a capacitor. I charged my capacitor up to 10 volts. A thing to be careful on yours is be careful because there is a volt limit. This one has a 10 volt limit, but if you're reading your capacitor and it has a 5 volt limit, well, then don't put 10 volts in. Now, this thing is charged, and if you touch the positive and negative together, the charges would just run through the circuit basically unhindered. So I don't want that. In my circuit, I want it to power a switch and a light bulb. So what I'm going to do is I'm going to hook it up, but I'm going to leave the switch unconnected. What this will do is it will let me control when this discharges from the capacitor. So if you haven't hooked up a circuit before, here's what's up. I've got my power supply going from positive to negative. So I've got my positive wire. This is connected to a switch. And when I'm ready to start my circuit, I'm going to close that switch. Basically, it's like a little drawbridge, and when the bridge is down, electrons can flow through it. So, tracing my path, electrons could be going through the circuit, through the wire, through this light bulb, and back. So to discharge a capacitor, I'm going to put it into my circuit, close the switch, and measure whatever it is I need to measure about charging or discharging this capacitor. So one more time, we use the power supply to charge up the capacitor, remove it from the power supply, and now my capacitor powers this circuit. All right, everyone, best of luck.